What's up, everybody? Welcome back. Moving on to another question. We have to determine dy by dx, and we're not going to simplify it. So we got y equals the fifth root of x squared plus 2x plus 1 over x squared plus 1. So notice that this function, we are adding two expressions, so we can take the derivative of each of these expressions separately. Now, this fifth root of x squared, I like to take any radicals and then change them to rational exponents. So fifth root of x squared, we can rewrite that as x squared to the power of 1 over 5. Right? Fifth root of something is the same as that something to the power of 1 over 5. Then we could just multiply those exponents. So the fifth root of x squared is the same as x to the power of 2 over 5. So I'm going to write that here, and now I'm going to take the derivative of both of these expressions. So starting off with this first one, 2 over 5 comes down, right? We're just going to use the power rule. So x to the power of something, we bring the exponent down, then we subtract 1 from the exponent. 2 over 5 minus 1 is like 2 over 5 minus 5 over 5, which gives us negative 3 over 5. And then this expression here, notice how it's a rational function, so we can apply the quotient rule. So we would take the derivative of the top, which is 2, multiply it by the bottom function. Then we're going to subtract the top function, 2x plus 1, multiplied by the derivative of the bottom function, which is just 2x. And that's going to be all over the bottom function squared. And that there is your final answer. If you want to make this one look a little nicer, you can bring this x down, so we can rewrite this as 2 over 5x to the power of 3 over 5. So we brought that x to the denominator, change the exponent to be positive. And then if you want to rewrite it as radicals, you can write it like that as well. So different ways to write this, and then here we're not going to end up simplifying that. We're not even supposed to simplify. So you could have maybe even left this like that, but if in case your teacher wants positive exponents, just bring it down to the denominator. And then this expression we would just leave as is. So the derivative of this function is this expression plus this expression there.